It's not always possible to measure very precise numbers in science, and especially in astronomy. It's not always possible and it's not always required. Very often in science we're able to go quite far with rough estimates. So estimation is a very powerful technique for getting you approximately to the right answer. If an estimate is within a factor of 2 of the correct answer, in astronomy that's often good enough. Sometimes the idea and the physical calculation is so uncertain that we're only sure within a factor of 10, which is called an order of magnitude. In any case, it's useful to be able to manipulate numbers so as to produce an estimate. The task of estimation is a useful skill that all scientists possess. For example, how many sheets of paper does it take to reach from the Earth to the Moon? If you could measure the thickness of a book and from that deduce the average thickness of a piece of paper, and you also knew the distance from the Earth to the Moon, you could produce this estimate. You might be surprised at the number. It's about 5 trillion. 5 trillion pieces of paper or pages stacked up to reach from the Earth to the Moon. That's about the same number as the printed pages in all the books on Earth. If you actually made one piece a dollar bill, that number, 5 trillion, is about the sum of all the budgets of the major economies in the world. This is an example of estimation. If you want to see how smaller numbers compare, you might imagine or estimate the size of the pile of the piece of paper of dollar bills that amount to your bank balance, and you might only find that it's about as high as a person is. The richest person on Earth has a bank balance that would reach 20 or 30,000 miles into the sky.